Have you ever stopped to think that when you eat might be just as critical as what you eat? And no, I'm not talking about another diet fad. This is about a pattern of eating that has incredibly deep biological roots, something our bodies might actually be hardwired for. Today, we're going to take a clinical look at the real science behind intermittent fasting. So here's our game plan. First, we'll dive into our ancient eating blueprint. Then, we'll get into the nitty-gritty science of what's happening inside you when you fast. Flipping that metabolic switch and turning on your body's own cleanup crew. And finally, we'll look at how this all works in the real world and tackle the all-important safety questions. All right, so to really wrap our heads around intermittent fasting, we actually need to rewind the clock way back. Because the way most of us eat today, 3 square meals, snacks on demand, that's a really, really recent thing in the grand timeline of human history. I mean, think about it, right? For most of us, this is just normal. Our whole day is built around breakfast, lunch, and dinner, with maybe a few snacks sprinkled in. But what if, from an evolutionary point of view, that constant eating is actually the weird part, the exception to the rule for our bodies? It's really a tale of two diets. On the left, you've got our ancestors. They didn't have a pantry down the hall. They lived in these feast and famine cycles, so their bodies got really good at running efficiently for long stretches without any food. Now look at the right. That's us. We live in a world of constant abundance. And that means our bodies are pretty much always in a fed state, and we almost never get a chance to fire up those ancient survival programs. So what actually happens when we intentionally create those breaks from eating? Well, it's way more than just giving your stomach a rest. When you fast, you trigger this really profound shift in how your body gets its energy. It's a process called the metabolic switch. And this right here, this is the main event, the metabolic switch. Your body's default setting is to run on glucose, sugar, from the food you just ate. But when you fast long enough, you burn through all that available sugar. And instead of hitting a panic button, your body just, it switches gears. It starts tapping into your fat stores, breaking them down and turning them into this amazing alternative fuel called ketones. And you know what? This switch flips a lot faster than you might think. For most of us, after just 8 to 12 hours of not eating, those ketone levels in your blood start to go up. That's the moment your body starts shifting from being a sugar burner to a fat burner. The key thing here is that this isn't some extreme starvation mode. It's a totally natural, built-in metabolic pivot. This diagram shows us exactly how it all goes down. So first, your fat tissue releases these things called fatty acids into your bloodstream. They cruise on over to the liver, which basically acts like a power plant, converting them into these super efficient energy molecules, ketones. And from there, those ketones get shipped out all over the body, providing this clean, powerful fuel for your muscles, your heart, and, this is a big one, your brain. And this leads to a really crucial takeaway. Yeah, weight loss can definitely happen with intermittent fasting, but the benefits that have scientists so excited, they go way deeper. They're happening at the cellular level. This isn't just a simple calories in, calories out equation. It's about waking up these ancient protective programs that are coded into our cells. And speaking of those cellular programs, one of the most powerful things that fasting kicks into high gear is a process that acts like a full-on deep cleaning service for every single one of your cells. The process is called autophagy. It literally means self-eating. Now, don't worry, it sounds more dramatic than it is. Just think of it like your cell's internal recycling and quality control team. When autophagy gets turned on, it starts hunting down old, broken, or junk parts inside the cell, breaks them down, and then recycles the raw materials to build new, healthy parts. It's fundamental for keeping our cells young and healthy. This chart here kind of shows us how it all connects. You see, fasting puts a little bit of good stress on your cells, and in response, they switch from growth mode to repair and protect mode. You can see right here how that stress resistance leads to some amazing things, like boosting DNA repair and, there it is, ramping up autophagy. Basically, fasting is a signal to your cells that says, all right, team, pause growth for a bit. It's time to clean house and make some repairs. Okay, so the science is clearly compelling. But how do people actually put this stuff into practice? Let's take a look at the most common and well-studied ways to do intermittent fasting. You'll usually see 3 main methods in the research. First up is time-restricted eating, and the most popular version is 16-8. This is a great starting point for a lot of people. You just eat all your meals within an 8-hour window each day. Then you've got the 5-2 diet, where you eat totally normally 5 days a week, and on 2 days that aren't back-to-back, you cut your calories way down. And finally, there's alternate day fasting, which is definitely more intense. You basically alternate between a normal eating day and a fasting day. And the results from clinical trials can be really, really striking. I mean, check this out. This data is from a study where healthy people did alternate day fasting for just 22 days. Sure, they lost some fat mass, about 4%, but look at that last bar, a 57% drop in their fasting insulin levels. That's incredible. It just goes to show how powerful fasting can be for improving your metabolic health, and that it's about so much more than just the number on the scale. Now, from a clinical point of view, the idea is not to just jump into the deep end. This chart shows how a doctor might actually guide a patient through this. You start slow. Maybe in month 1, you just try a 10-hour eating window. Then, over a few months, you gradually work your way down to 6 or 8 hours. The key takeaway from a doctor's perspective is that this has to be sustainable. And that brings us to what is, without a doubt, the most important question we can ask. The science is fascinating, the methods are clear, but is this actually safe for everybody? And the short answer to that is a clear no. First off, it's really important to be realistic. There's an adjustment period. When you first start, your body's going to have to adapt. It's really common to feel hungry, maybe a little irritable, or have a bit of brain fog. But the good news is, for most people, these side effects are temporary, and they usually fade away within about a month as your body gets the hang of this new rhythm. Okay, and this part right here is absolutely critical. Intermittent fasting is not for everyone. You absolutely must talk to your doctor before trying any kind of fasting, especially if you fall into any of these categories. If you're pregnant, have a history of an eating disorder, if you have a chronic illness like diabetes, or if you're on medications for things like blood pressure or blood sugar. This is a powerful tool, and it has to be used safely, with medical guidance. So, after digging into our evolutionary past and the amazing science of our cells, we're left with this really big idea. We spend so much time and energy obsessing over what we eat, but maybe, just maybe, the simple, ancient question of when we eat holds an equally powerful key to our health.